Let's go ahead and start. We have a little bit presentation. Thank you guys for coming. My name is Zain Marvi. I work with Rackspace Technology as a cloud architect with the Rackspace cloud team. Vijay, Kovvuri, which is one of my mates, couldn't be here today, but he did help me with the presentation, and we've been working together on project to see how we can incorporate that for our customers. So kind of just going off the agenda, let's do a Masakari overview. We're just going to kind of go over, what this is, how it's happening, and then we're going to go through the Masakari components, right? We're just going to look under the hood and go over what all the different functions are and how they're used. And then we'll do a little bit more deep dive on Masakari instance introspection, which is basically the kind of the VM recovery aspect of Masakari and see how that works. And then just finally, I'll show a slide with links to how to contribute, where the upstream code is, and how to file bugs. One of the things that we need is people to kind of be interested and contribute the project. So it's something that is really highly looked into, especially with the whole VMware OpenStack migration. One of the big features that customers have. All right, so just kind of go over an overview. VM high availability project, Masakari, first released in the version of Rocky. The goal for Masakari really is to handle VMware failures by enabling automated recovery process for the following events, right? So of course, right, you have your number one thing is hypervisor failures, right? So, computer crashes, loses connection to the network, power, right? So those type of things. Another thing that Masakari can also watch is making sure that the libvirt engine process is running in case of any kind of failures on the hypervisor itself to cause that process to die. Masakari will be able to watch and keep that process back on as well to recover the instance. Also, inside the instance, right, we do have using QEMU guest agent to watch and get a heartbeat for the VM itself. And if that loses that heartbeat, then Masakari will then also, using introspection, be able to recover that instant. Some installation methods you guys can use, right? Main one we use in-house at Rackspace is OpenStack Ansible, and then also we'll be using OpenStack Helm as well. That was one of the links I didn't post up there. I just realized, I forgot that add that as well. But also with Cola Ansible, you can enable Masakari. Same with Charms, and then OpenStack platform, Red Hat OpenStack platform. Now that it's changed, it's a different, probably a different process using OpenShift, right? But back, I think if you look at OSP 2, they had a high availability. So if you want to documentation there on the slides. This is just kind of showing a diagram basically of how it works out. So you have your main components, right? The Masakari API, which will then process API requests, of course, talk to the database, send RPC messages to all the different the Masakari monitors and the Masakari engine. Now, the Masakari engine will be kind of the middleman here to actually talk to Nova. And if there are any events that Masakari register, it'll use Masakari engine to then talk directly to Nova to say, hey, go ahead and power off this VM, go ahead and start this VM, or in case of a host failure, right, disable this node from the scheduler and then initiate a Nova evacuate those instances off the failed host. And to do that with the host recovery, right, you'll have another driver, right? So that'll either be Pacemaker, right, using Pacemaker or Pacemaker Remote, and also Consul, which is kind of a new, relatively new feature that came out, got implemented in the code about 3 years ago. So for our lab, we actually used Consul to be kind of post-monitor driver. If you do install it, you actually be able to see a Horizon dashboard tab on there. It says Instance HA. Now, this is where, as an administrator, you can manage or set up your segment. So let's say if you have, for a given cluster, you have multiple availability zones or aggregates, you can actually create segments in a single cluster and then assign those hypervisors to those segments, right? And then with those segments, you can then apply we call a evacuation strategy, right? Or a reserved host instead of a reserved host. So I'm not going to go into too detail in that regard, but this is where you would set those kind of configurations if you want to customize your segmentation of different hosts for different evacuation strategies. And then right here on the far right, you have the notifications. So anytime Masakari gets or an event is triggered or seen, Masakari will create a notification ID and then assign the UUID to that notification and then apply it to a specific host. And with that, you can actually get more details. If you click in, you'll see what it's actually doing, when it actually started, and then some progress details of the event steps that it went through. And it will show you if it successfully succeeded or failed, right? So if you look at the status, you'll see that either finished or ignored or aired out or failed. Going under the hood itself, so the two main services that live on the controller will be the API, of course, and the engine services. For the API, that will be your typical API requests, using RPC as well, and then also updating the database for Masakari, mainly with notification segments. That's the Masakari API will directly, talk and change. The engine, as I mentioned before, right, will be kind of processing the notifications that come through. And if those notifications are confirmed, then Masakari will then directly talk to Nova to actually execute those recovery steps. There are baked-in recovery workflow steps via Python scripts, and there are ways to actually customize it, but it's a little bit more granular. There is documentation on that. Now, Masakari monitors, this is the kind of the big one. This is the one that actually, these are the agents that live on the hypervisor themselves, right? And there's four main agents that live on the hypervisor with Masakari monitors. First, we'll have the instance monitor, and that will be the agent to detect VM libvirt domain events, right? So, for example, if one of the domains suddenly just crashed, right, and it goes from running to stopped for no reason, it'll actually send a notification. Then Masakari is actually smart enough to know that did Nova actually power off this instance or not. If it didn't, then it'll actually immediately create a recovery workflow to automatically take that instance back on, because Nova did not actually send a signal to actually stop that instance. So that'll keep it uptime. One of the things that needs to be added is having a metadata property, and that'll be HA enabled equals true as a property flag on the VM. If that's not there, then Masakari will ignore. So that's one of the requirements. So actually have that. And there's sometimes where you want to ignore. There's certain instances that you want to have an administrator manage in case something goes bad with it. So you don't want Masakari, trying to manage everything, especially with a complex environment with different sets of VMs running. Process monitor is one of the ones that are kind of low priority, but it does allow to manage systemd level events on the hypervisor itself. So you can have it with the process list, you can have it manage all the different, for example, like Prometheus, right? If you have a Prometheus monitor and you want to have it make sure that it's constantly running, if it dies, then Masakari will actually just kick that sucker back on. And by default, they actually will monitor SSH and then all the other components from Masakari to make sure that they're running. So you can actually set attributes to make sure that, okay, how long, or check every 30 seconds, and then however many samples it'll get before it determines that, hey, okay, I need to restart this process because it's actually dead and not just constantly restarting. So, and then the final one is instance introspection. This is the one that will go a little bit more depth. This is where it'll detect VM level events inside the VM. So for example, if it kernel panics, or if it locks up or ooms, then with introspection, Masakari will be able to detect it, and then the default recurring workflow for that, once it's confirmed, is to hard power off the VM, and then once it completes that, then it'll start the VM back up. Also, another thing, you need to make sure that any VM that you want Masakari to manage to have that initiating is true, for instance. Now, the big kahuna, right, is Host-Monitor. This will be for hypervisor failed events, right? So with Host-Monitor, it lives on all the different hypervisors, and what it does is it kind of creates like kind of a cluster, so all the computers are watching each other, and it does this with a Host-Monitor driver, right? So for everyone that's familiar with OSP, right, pacemaker. That's kind of the out-of-the-box solution with Masakari for certain deployments. One of the new ones is using Consul monitor driver. We noticed that Consul is a little bit more easier to deploy and manage. If anyone used pacemaker and how frustrating it is sometimes. Also, you need to manually kind of do resource cleanups yourself as an administrator, which if anyone dealt with LSP. So using Consul, that was one of the kind of the features to kind of make that a little bit easier. Plus, with Consul, you can actually monitor multiple interfaces for a given hypervisor itself. So with Pacemaker, you can monitor the heartbeats for one interface only. But with Consul, you can have a mesh system to the management interface, you can monitor the storage interface, or the tenant interface for VXLAN traffic as well. And you would use like a matrix, right, to then determine whether to initiate the automated recovery workflow. So that's one of the advantages with Consul right now. And that's what we kind of use around that as well. Host evacuation strategies. I think I might have mentioned this earlier, but when you have a cluster with different kind of segmented aggregates or availability zones for different sets of hypervisors, depending on what their use cases are, right? Let's say if you have hypervisors that need specifically for GPU VMs, enable PCI pass-through VMs, you don't want your database VMs end up actually migrating to those type of hypervisors. So with those evacuation strategies, you can actually segregate your availability zones and also use different evacuation strategies, which for that case, you wouldn't want to use like a reserve host where it will evacuate all the VMs with reserve hosts as destination nodes using the Nova scheduler. So if you have an availability zone with a segment, all those hosts, and you have with a reserve host, that VM or that hypervisor fails, then the VMs from that hypervisor will then only evacuate to that other availability zone. If you use auto, which is kind of like the standard out of the box default evacuation strategy, then those VMs can suddenly just scatter to different nodes. Now you can also have what we call aggregate level filters, I should say, with the scheduler to prevent that. But Masakari does have that feature to allow for reserve hosts. Some limitations and considerations to consider, right? There's no one size fits all config. Every environment is going to be completely different depending on use cases. If you have a very large environment, you also need to make sure that there are specific tunings that you need to set. Sometimes with timeouts, right, to make sure that a VM is actually truly down, you don't want to have your evacuation threshold be like 5 seconds, right? You want to make sure that that VM is really truly down. So sometimes you'll set it to 60 seconds because sometimes if a VM does have a crash reboot, you don't want Masakari to come in and start, shooting it or trying to restart it constantly, even though it's coming back on its own. Right? So you want to kind of keep that in mind, right? With your tunings. Right? Also, there are sample configurations where it'll notice that the VM is down, but then it'll wait another 60 seconds and then get another sample. And if it hits that threshold, then it'll immediately activate the recovery workflow. Another thing is, big thing with, especially with host evacuation, you have to have shared storage on the VMs, right? So if you have VMs that actually have disks in varlib Nova, then as regular block devices, then it's not going to work. Those instances will error out when it tries to evacuate. So that's one of the big kind of caveats with Masakari being implemented. But now I think with cloud strategy being the way it is, a lot of people are going that route to have a shared storage backend rather than everything living on the disk living on the computer itself. There are some high performance computing customers that do have it where the disk is living in like NVMe on the hypervisor itself, or to have fast I/O. But for the most case, then you need to make those considerations, right? Also, another big consideration or limitation is if you do have a cluster that has almost like 90% utilization on all your computers, if you have a host that fails and you need to evacuate, if there's not enough resources on another hypervisor, then of course those instances might go into just something to keep in mind. Okay, so just a little bit on introspection, since I know that there's 5 minutes, so I will kind of speed through this a little bit. With this introspection, right, is detection of system level failure events using the QEMU guest agent. If anyone uses Proxmox, right, they probably had it used QEMU guest agent for their VMs, right? So a similar concept. What you'll do is you'll install guest agent. So if it's Ubuntu, it's actually on your standard repos, and you just need to install QEMU guest agent package on the VM itself. And then when on your next boot, it'll just do a systemd start. That will kick it on. One of the things that needs to be enabled on OpenStack is you'll need to make sure that you set a glance property for enabling hardware QEMU guest agent enablement, so that the live domain will create that socket connection for QEMU. Also, you'll need to have the HA enable property, of course. I did put a little thing here to how to add that in Horizon, but most of you guys will probably be able to understand how to just kind of show you kind of the instance recovery with PBS agent. As you can see here on the dashboard, right, it actually registered. Yeah. So as you can see here, right, Masakari did register the notification here, and once the notification is confirmed, it'll do the recovery workflow. And you can see the progress details. You can see that it stopped the instance and it confirmed that it's been stopped. Right, it does like a hard power off basically, and then it'll try to start the instance immediately after and kick it back on. Now this only happens once, so once that recovery workflow happens, if the VM is just not coming back online, it's like, all right, then it will have to be up to the administrator to come and solve that, right? So it tries for the first time and then it just gives up. So that's kind of one of the limitations with the introspection right now. I did put some steps in the slides on how to actually kind of bake that in, right? So if anyone doesn't know how to kind of bake images using Word Customize, this is some way to do it. Kind of one of the steps, right? You need to make sure that the libguest tools are installed on the node or local host or image build host that you have, right? And then you can pull the actual cloud image from a string or from your local repository itself. And then you can actually use Vert Customize to install the QEMU guest agent. And then from there, you can upload it right back into Glance, or even with the running instance, you can actually install the agent directly and then create a snapshot and recreate an image from that as well to enable that from us. I did put a link for Windows image builds For its Windows, it's a little bit more involved. Similar, if anyone built a Windows image, you have to install the VirtIO drivers. So if you do plug in the VirtIO drivers, you'll see an actual directory for the Creamy Guest agent as well. So that's something you would install if you want to have your Windows VMs be managed by us as well. And finally, we just have the links to the documentation for anyone that wants to check them out. At the top here is just the upstream or from docs.openstack.org. We do have kind of processing guides and API reference guides as well. And then just if you guys need for filing any bugs and also Launchpad, I put links here for Masakari and Masakari Monitor. So Masakari and Masakari Monitor is actually two different, I guess, two different repos technically. So with any changes that happen in Masakari won't actually transition to Masakari monitors. So when people make bugs, sometimes they get confused, and so they'll make a bug report for the Masakari monitors and the Masakari monitor Launchpad. So there's some kinds of confusion. I noticed that when I checked it out. So just to kind of keep that in mind. But we do really need people to kind of, you know, contributors and people to kind of test this code out. The commits are not as, it's few and far between. I think the last commit, I think it was like 8 months ago for one of the Masakari monitors. The fix introspection, actually, there was a bug from transitioning from Python 2 to Python 3, actually. But there's certain other things that need to probably get patched. So we just need, I need more eyes on this project so that people can contribute more to it. Because it's going to be a great solution for people, especially, like I said earlier, with anyone that's transitioning off VMware. They're going to want that VM recovery aspect because VMware's got it right out of the box. So, yeah. So I appreciate that. So if anyone has any questions, please let me know.
Yeah. So one of the questions I always have when it comes to Masakari is, you know, one of the reasons why you want to use like PaceMaker Remote is for the Stoneth capabilities.
Yes.
You don't have corruption of the shared data source with writes.
Right.
So using Consul in that particular scenario, about that from
yes, that is one of the things that we consider about Consul and the lack of Stoneth ability, and we're trying to figure out ways to kind of get around that, and so that's kind of the brainstorm sessions I'm trying to have right now, as to how to enable that. Because with PaceMaker, one of the things with out of the box is that PaceMaker limit, right, is 32 nodes for a scene cluster. So of course with PaceMaker Remote, you'll be able to do that, right? So that's why kind of PaceMaker wins a little bit, but PaceMaker, as we know, is a little bit clunky sometimes to use. So that's why we were trying to get the Consul to work properly. And so that's where we're still trying to test them. What else, guys? All right.